Welcome to Basic Advanced Math. Today we are continuing Calc BC. I hope you're doing well. I'm doing well. We're going to go ahead and knock out these series. We're going to learn some new stuff today, and we're going to get smarter. So today I'm introducing you to geometric series. I'm introducing you to series altogether. Series is going to be a pretty big part of calculus moving forward. You're going to be doing a lot of manipulation with series. However, the first and most basic type of series that you're going to see is a geometric series. So I'm going to go ahead and show you what a series is and what this looks like, and we're going to move on from there. So basically, this is the symbol for a series. This sign right here is the sign for a series. N equals 0 is the integer that you start from, and this top number, which in this case is infinity, is the integer that you stop at. Basically, what this is saying is, as you start from 0 and count up every integer, it's going to add every number that you get. However, n is going to be plugged into this formula right here, which is p to the n. So say p, we're going to put in a number. P is always going to be your number. If p is 1/3, then we would say that it's the sum from n equals 0 to infinity of 1/3 to the n. This may seem like a lot going on. It's really not. We're adding the numbers 1/3 to the 0, plus 1/3 to the first, plus 1/3 to the second, plus 1/3 to the third, and so on, keep going to infinity. Now, in certain cases, you can actually find the exact number that this is going to reach. In certain cases, it will not go past a certain point, and this point that it stops at and that it almost reaches is called the convergence point. This is going to be the final sum of all the numbers. However, in other cases, the numbers will go on forever and ever and ever and keep getting bigger and never stop. Those are called divergent cases. When the numbers keep getting bigger and bigger and bigger and go on to infinity, it's called divergence. As you can tell from the word, it means going away from something, which means that it is going to keep going away from 0. The opposite, however, if a sum keeps getting closer and closer to a certain number, say 5, it'll get to 4.999 and 4.99999 and keep getting closer and closer to 5, but it never actually reaches 5, then we say that it converges. We also say that the convergence point is 5 because this is the number that it will never reach. However, it will get infinitely close to 5 as we keep getting closer to infinity and adding all the numbers up. The formula to tell whether it diverges or converges is right here. We have to know these two. If p is between -1 and 1, we know that it converges. So like I said earlier in this example, if p is 1/3, we know that it will converge to a number. We don't know what that number is yet. We'll get there, but we know that it converges to a number. On the other hand, if p is less than or equal to 1, or if it's greater than or equal to 1, say it's -5 or 6, then it diverges. It will keep on going forever and ever and ever. There's no point in trying to find the convergence point because it will never stop at a number. Now, how to find out what the number converges to, if it converges to anything. So you found out that it converges to something. You found out that p is in between -1 and 1. How do you find out what it converges to? There's a very, very simple formula for that. It is 1/1 minus p. This may look super simple. However, that's because the geometric series is pretty simple, and finding the convergence point is pretty simple. Now let's go over an example, and I'm going to show you exactly what this means and how to find the convergence point. So we have our example right here. We have the sum as n goes to infinity of 2 to the n over 3 to the n. Now, you'll notice that this is in a weird format. We didn't see this before. We saw a single number raised to the n. However, this is the exact same thing. 2 to the n over 3 to the n is a form of the number that you're going to see often. What you can actually do is rewrite this entirely. You can rewrite it as the sum from n to infinity of 2 over 3 to the n. Now we have it in a form that we can work with because we can see that this number right here is p. What a great rectangle. Okay, we see that this number right here is p. Now we have all that we need. We can tell that it converges because p, which is 2/3, is less than 1 and greater than -1. So we have the convergence. Now we just need to find the convergence point. All we have to do is plug it into this formula right here. So let's go ahead and do that. Now we have it plugged in. It's simply 1/1 minus 3. We plugged in the p number that we got into this formula, and we have this. Now it's simply calculating the number. If you have a calculator, you want to go ahead and plug it in. If you want to do it by hand, it's a little more difficult, but It's not the most difficult thing that you're going to do. Either way, you're going to end up with the answer of 3/2. And this answer of 3/2 is the final answer. As you go from 0 to infinity of 2/3 to the n, you're going to get very, very infinitely close to the number 3/2. You're never going to reach it. As you are going to infinity, you can say that this is the limit. This is the convergence point. That's about all that you're going to need to know for geometric series right here. We're going to have more series coming in the future. A series, like I said, is going to be a pretty big part of algebra. Nope, calculus. Calculus. Other than that, as long as you can get it in a form like this, you can figure out what P is. You should be able to easily calculate the convergence point, whether it converges or not. Other than that, until next time, hope you guys do well. I believe in you.